Welcome back to Smarter Green Living. In a world of conflicting headlines and heated debates, one question remains. Should we believe climate change scientists? To find out, we have to look past the noise and follow the evidence. It's true that Earth's climate has always changed, driven by natural cycles over thousands of years. But the speed and nature of what we're seeing today point to something entirely different. The first clue is the warming itself. It's not an assumption. It's an observation, measured by a global network of satellites, weather stations, and ocean buoys. As temperatures rose, so did carbon dioxide. By drilling into ancient ice, scientists have found that CO2 levels have surged since the Industrial Revolution, reaching heights unseen in human history. But where is the extra CO2 coming from? The chemical signature, the fingerprint, of the carbon in our atmosphere points directly to the burning of fossil fuels. The physics are well established. CO2 acts like a blanket, trapping heat that would otherwise escape to space. It's a simple mechanism with profound consequences. If the sun were responsible, the entire atmosphere would warm. Instead, we see the lower layer warming and the upper layer cooling, the exact signature of a greenhouse-driven change. This isn't just theory. Predictions made decades ago, from shrinking Arctic ice to rising ocean heat, are now our observed reality, matching the science with remarkable precision. Skeptics are right to demand rigor. Science involves uncertainty, and policy debates are complex, but the physical evidence of warming is independent of political opinion. When we test political doubts against the evidence, the checklist is clear. No other theory explains the rising CO2, the ocean heat, and the specific fingerprints we see today. When thousands of independent lines of evidence converge on one conclusion, the picture becomes clear. The science isn't a matter of belief, it's a matter of data. The real challenge isn't whether we believe the scientists. The challenge is what we choose to do with the truth they've uncovered. Should you believe climate change scientists, especially when powerful public figures have repeatedly questioned climate change, called climate warnings exaggerated, and suggested that the whole subject is being used to control economies, energy choices, and ordinary people's lives? Do you think it's fair to question what the scientist says? Because whether you agree or not, this argument connects with you. There are talks where experts, politicians, activists, businesses, and the media often speak with so much confidence that the average person is left wondering whether they are hearing the truth or exaggerated propaganda. History has shown us that experts can be wrong, and public debates can become so political that evidence gets buried under emotion. So instead of asking whether we should believe climate scientists, I want us to consider this. If we ignored the politics, ignored climate activists, and looked only at the evidence, what conclusion would you as a reasonable person reach? By the end of this video, you won't feel that you have been told what to believe, but walked through the argument carefully enough to decide whether the evidence points towards climate change being real, human activity playing a major role, or whether the skeptical arguments explain the evidence better. One of the strongest arguments used by climate skeptics is that the climate has always changed, and that is completely true. The Earth did not suddenly begin changing when humans invented cars, factories, aircraft, or power stations. Long before industrial society existed, the planet experienced ice ages, warm periods, changing sea levels, major droughts, volcanic disruptions, and dramatic shifts in ecosystems. There were times when huge ice sheets covered large parts of the northern hemisphere, and there were other times when parts of the planet were warmer than they are today. But the problem is that the climate has always changed does not tell us what is causing the change we are seeing now. You can compare this to standing in front of a burning forest and saying, "Forests have always had fires." Yes, they have. Some fires are caused by lightning, some by natural conditions such as heat, and some by human carelessness or deliberate action. But the fact that forests burned in the past does not explain the wildfires experienced today. There is need to investigate the cause of each specific fire. That is exactly what climate scientists are trying to do when they investigated the current warming. The evidence does not fit natural causes alone. And because the climate has always changed, we need to know what is driving these changes we are seeing now. Before we even discuss carbon dioxide, fossil fuels, or climate models, the simplest change is that the Earth has become warmer. Global temperature trends are measured using weather stations, ocean buoys, ships, satellites, and independent scientific organizations across different countries. These methods are not identical, and the people analyzing them are not all sitting in one room agreeing what answer they want. Yet the broad conclusion is the same. The average temperature of the planet has risen significantly since the late 19th century. Now, that alone does not prove humans are responsible. If we want to be real, we have to admit that warming by itself only proves that warming is happening. It does not yet prove the cause. So the next step is to ask what else changed during the same period and whether that change has a physical connection to temperature. This leads us to the second clue. During the same period that global temperatures began rising, carbon dioxide levels in the atmosphere also rose sharply, especially after industrialization expanded across the world. Again, this is not a guess. Carbon dioxide is measured directly in the modern atmosphere, and scientists can also look further back in time using ice cores from places like Antarctica and Greenland. These ice cores contain tiny bubbles of ancient air, almost like sealed samples from the past, allowing scientists to compare today's atmosphere with the atmosphere from hundreds and thousands of years ago. What those records showed was that carbon dioxide levels were relatively stable for a long period before industrialization, and then they began rising quickly as humans burned more coal, oil, and gas. But even then, because two things rising at the same time does not automatically mean one caused the other. So where is the extra carbon dioxide coming from? Because carbon in the atmosphere carries a kind of chemical fingerprint. Fossil fuels were formed from ancient plants and organic matter, and because of that, the carbon released when we burn coal, oil, and gas has a distinct signature. Scientists can analyze the changing mix of carbon in the atmosphere and compare it with what they would expect from fossil fuel combustion. The result is that much of the extra carbon dioxide carries the fingerprint expected from burning fossil fuels. At the same time, atmospheric oxygen has been declining slightly, which also matches combustion because burning fuel consumes oxygen, which supports the school of thought that carbon dioxide has increased in a way that points back to human activity. If the planet is warming, carbon dioxide is rising, and the added carbon dioxide largely matches the fingerprint of fossil fuels. How does carbon dioxide warm the planet? Carbon dioxide is natural, and skeptics are right to point that out. Plants use it, animals produce it, and it has always existed in the atmosphere. But saying something is natural does not tell us whether too much of it can cause harm. Water is natural, but a flood can destroy a town, and I am sure you are careful with fire, because in the wrong place can be fatal. Same way, carbon dioxide is natural. Is there any proof that increased concentration changes the way heat moves through the atmosphere? The reason scientists focus on carbon dioxide is that it absorbs infrared radiation, which is heat energy leaving the Earth. In simple terms, sunlight comes in, the Earth warms, and then the Earth tries to release some of that heat back into space. Greenhouse gases slow down part of that heat loss. They do not create heat from nothing. They reduce the rate at which heat escapes. A simple way to imagine this is like adding another layer to a blanket. Your body is still the source of warmth, but the extra layer keeps more of that warmth from escaping quickly. So if humans increase the amount of a heat-trapping gas in the atmosphere, We should expect the Earth to retain more heat. But good science does not stop at theory. It asks whether the real world behaves the way the theory predicts. And this is where climate science becomes even more convincing. If greenhouse gases are causing the warming, then the atmosphere should show a particular pattern. The lower atmosphere, where we live, should warm, while the upper atmosphere should cool. That might sound strange at first, but it makes sense because greenhouse gases trap more heat lower down, while less heat escapes upward into the higher atmosphere. If the sun were the main cause of modern warming, scientists would expect a different pattern, with both the lower and upper atmosphere tending to warm together. Observations show the lower atmosphere warming while the upper atmosphere cools. That is key because it does not simply show that warming is happening. It helps identify the likely cause of the warming. It is like finding not just smoke from a fire, but a matchbox, footprints and security footage pointing in the same direction. And once scientists saw this pattern, they did not stop there. They made more predictions, and those predictions are one of the strongest reasons the evidence is taken seriously. Climate scientists predicted that as greenhouse gases increased, global temperatures would rise. They predicted that the Arctic would warm faster than many other parts of the world because melting ice exposes darker surfaces that absorb more sunlight. They predicted that sea levels would rise because warmer oceans expand and melting ice adds water to the oceans. They predicted that oceans would absorb most of the extra heat trapped in the climate system. They predicted that nights would warm faster than days because greenhouse gases reduce heat loss after sunset. Many of these predictions have been observed. The Arctic has warmed faster than the global average. Sea level has risen. Ocean heat content has increased. The lower atmosphere has warmed while the upper atmosphere has cooled. Nighttime temperatures have increased in many regions. These are not perfect predictions in every detail, and climate scientists have made mistakes. But the broad direction of many major predictions has matched reality. So when climate scientists predicted several major patterns and the real world later moved in the same direction, it became harder to dismiss the science as guesswork. But to be fair, we still need to examine the strongest skeptical arguments. Climate skeptics are not wrong about everything. They are right that climate has changed naturally before. They are right that climate models are not perfect. They are right that some media headlines exaggerate individual weather events. They are right that not every storm, flood, or heat wave should be lazily blamed on climate change without proper evidence. They are also right that climate policy can be expensive, disruptive, and sometimes badly designed. But none of those points by themselves disproves human-caused warming. They mostly remind us to be careful, honest, and precise. Climate models having uncertainties does not erase the thermometer record, the ocean heat record, the carbon isotope evidence, or the physics of greenhouse gases. The climate changing naturally in the past does not prove the current warming is natural. Politicians exaggerating climate claims does not mean the underlying science is false. Bad policy does not cancel good evidence. You can question climate policies while still accepting the evidence for climate change. Those are not the same. When politicians question climate change and minimize climate change impact, their concerns about policy does not negate the scientific evidence. The question is, which explanation fits the evidence better? Does the climate has always changed argument explain why carbon dioxide has risen so sharply since industrialization? Does it explain why the carbon fingerprint points to fossil fuels? Does it explain why the lower atmosphere is warming while the upper atmosphere cools? Does it explain why the oceans are accumulating heat, why sea levels are rising, and why predictions about Arctic warming have broadly come true? What alternative explanation that fits all the evidence can they offer? Should you believe climate change scientists? It's up to you. Do not believe them simply because they are scientists. But if you follow the evidence step by step, the conclusion becomes difficult to avoid. That does not mean every climate prediction is perfect, but it does mean the core argument for human-caused climate change is built on multiple lines of evidence, not just belief, politics, or doomsay. Are we confident enough to separate scientific evidence from politics and genuine uncertainty from controversial denial? So the next time someone says, "The climate has always changed," the answer is, yes, it has. But what is causing the change? And once you ask that question honestly, the evidence becomes much harder to ignore. If you found this useful, subscribe to Smarter Green Living, where we talk about sustainability, climate, and energy choices, and test them against the reality. Thank you for watching, and see you in the next video.